Hello everybody, I think it's time to get started. Welcome back. Um, one moment. Yes, okay. Uh, remember I said last time my plan for these Zooms is on Tuesday Zoom is going to be mostly me doing more examples. Wednesday Zoom I will do some examples and then I want to have time for you guys to work on the problems, and then Friday will be all you guys working on problems and doing the quiz at the end. I hope everybody is on board with the concept. Um, any questions about any of that before we get started? No. Great. So I want to do a few examples. Last time I did more examples about curve sketching and absolute extrema. This time I want to talk about the antiderivative, which is the next big thing. You know, actually the rest of the semester will pretty much all be about the antiderivative. Um, and individually, these problems are fairly easy to do. You just have to remember the rules. There are a few rules. So the basic one is the antiderivative of x to the n dx is 1 over n plus 1 x to the n plus 1. So this is how you do the antiderivative of a power of x plus c. You always put the plus c. This works as long as n is not equal to negative 1 when n is not minus 1. If n is minus 1, then that would make this denominator right here equals 0, and that's not allowed. So this formula cannot possibly work when n is minus 1. When n is minus 1, there's a special formula for that, and what you get is the natural log of the absolute value of x plus c. So that's a special rule that you have to remember in the case of a negative 1 exponent. You got it. You get the natural log. All right, and then we have some formulas involving exponential functions. So the simplest one is integral e to the x is, of course, just e to the x. There's also something with an exponential function which does not use e but some other base a. This is a to the x over ln a plus c. And then we have variations of those when there's an additional constant up top. So e to the kx, when there's an extra constant inside the exponent. These, unfortunately, you just have to remember these. 1 over k e to the kx. And then the most complicated is a to the kx dx. This is 1 over k natural log a to the kx plus c. So those are all the antiderivative formulas that you need to know. There's kind of a lot of them. Unfortunately, you got to remember them. Let's just do some examples. Once you know the formulas, the examples are not so hard to do. So let's start with a simple one with just polynomials. 3x to the 7 minus 4x cubed plus 7x minus 2 dx. The integral of this whole thing. What we have here is a bunch of things being added together or subtracted, doesn't matter. That means we can just do the antiderivative of each thing. And we also have coefficients, but the coefficients also don't really matter. They just end up as coefficients in front of the answer. So I can just say the answer immediately. This 3 there just becomes a 3 coefficient. And then what happens to x to the power 7? You do this to it. X to the power 7 is going to become 1 over 8 x to the 8. So what I get here is 3 times 1 over 8 x to the 8. So that came from the first part here, right? And then I do this one. 4x to the third, I go minus 4 times 1/4 x to the 4 plus, each time you just leave the coefficient like it is. 7 here is the coefficient, so I leave 7 like it is. And then what do I do with x? It's really x to the 1. You don't see the 1, but that's what it is, x to the 1. And so I increase the power by 1, I get x squared, and I divide by 2. So it's 1/2 x squared. And then finally, minus 2. When you have just a constant by itself, I suppose I didn't say that in my list of formulas, but what happens is you multiply by x. So minus 2x is the last thing. And then plus c, we always put plus c. So each one of these things just came directly from one of the things inside the integral. Any questions about that one? This is an easy one. All right, let's try another one. How about, here's one which involves some exponential functions. 2 to the, sorry, that's, we could do that one, but it's just not what I wanted. 8 times e to the 2x plus 3 to the 5x dx. How about that? Here we have two different exponential functions, and so you have to use the appropriate rules on the left side there. What do you get? First of all, the 8 coefficient doesn't really matter. I just leave it as a coefficient in my answer. And then what do I do with e to the 2x? Look at these formulas here, and it fits into this one, e to the kx, where k is 2. So what I get for the answer is 1 over 2 e to the 2x. And then I go plus 3 to the 5x. That one fits this last formula, right? It's not an e, so I have to use the ones with the a's. And then there's this constant up top is the 5. So I'm going to use this formula here, where k is 5 and a is 3. What we get 1 over 5 ln 3 times 3 to the 5x. And then I say plus c. And that's all there is to it. Any thoughts about that one? Any questions about that one? Nobody.
I have a question about the last one.
Yeah, sure.
When you had the negative 2 dx, what did you do there exactly?
When you have a constant, just a constant by itself inside the integral, it becomes that same constant times x. So that's just another rule you have to remember.
Okay, thank you.
Yep. All right, let's continue. I got a few more here. Come on now. How about integral of x plus 1 times 2x plus square root x? This one's a little cute. What's special about this is there is multiplication on the inside. When you have things added together on the inside, you just go down the list and you do each of the integrals of each of the things being added. But when it's multiplication, you've got to do something completely different. There is no, there's nothing like the product rule for an integral. Actually, there is something like that, but we haven't talked about it yet, and we're not going to talk about it. If you want to learn about that, then take Applied Calculus 2. I'm teaching it next semester, by the way. Anyway, you should, you got to take care of this multiplication. How do we do that? You should actually multiply it out, like do the FOIL in there, because you cannot just take the antiderivative when you have multiplication on the inside. Before I do that, would you mind if I just one step, I'm just going to rewrite the square root as a 1/2 power, as we always do. All right. And now I'm going to do the FOIL. Notice I am continuing to write the integral sign and the dx. That's because in these steps, I am not doing any antiderivative. I am just simplifying what's on the inside. I'm rewriting the same thing on the inside.
Wouldn't that 2 just be a 2, not a 2x? Oh, wait, never mind.
No. This one? Yeah, I'm just copying the same thing. Thank you for your concern. Let's do the FOIL. So I multiply the first two things. I get x times 2x, which is 2x squared, plus the outer things is x times x to the 1/2. I hope you remember what to do in that case. How do you multiply x times x to the 1/2? This is x to the 1, of course, times x to the 1/2. This gives me, you should add the exponents, and I get x to the 1 plus 1/2, which you could write as 3/2 or 1.5 if you like the decimals, however you like it. All right, that was the outer product. Now the inside product is 1 times 2x. That's just 2x. And then the product on the end is 1 times x to the 1/2, which is x to the 1/2. Can I write 0.5? Just since I wrote decimal for the other one, you might as well do it the same way. However you like. All right? And now, I'm ready to do the integral. Now this thing looks kind of like like that first one I did up here, right? We should be able to just go down the list and do the integral each time. The purpose of all of those intermediate or those preliminary steps was to deal with the multiplication properly. You can't just integrate with a multiplication. You have to turn it into addition. All right, let's go down the list here. So this time I'm not going to write the integral sign anymore because I'm actually doing the integral in this step. 2x to the 2 becomes 2 times 1/3 x to the 3 plus x to the 1.5. You increase the power by 1, remember, which means it becomes x to the 2.5, and then you divide in front by that same power. 1 over 2.5 x to the 2.5. 2x becomes x squared, right? 2x, if you like, is 2 times 1/2 x squared, but 2 and 1/2 can cancel. And then finally, x to the 0.5. I increase the power by 1. It ends up being x to the 1.5, 1 over 1.5 in the front. And then plus c, as always. You gotta love the plus c. All right, what do you think about that one? Any questions about that one? The moral of the story is when you see multiplication inside the integral, you better do something about that. Usually do the FOIL or something else. All right. This is a different answer than if you had just attempted to just like inside these parentheses do the integrals. You will get the wrong answer if you do that. Okay, I got just one more for us to try. These really, there's not a lot to them, although you have to practice these to get comfortable with it. But each individual one is pretty short. You know, they're not like super long like the curve sketching ones. How about this? In this case, I have a fraction. This is also a bad thing to see inside of an integral. You cannot just do the integral across the numerator and also across the denominator. It don't work that way. You have to somehow do the fraction, like do the division. To me, the easiest way to do this is to rewrite it, first of all, as a product. So I'm going to write 5x squared minus 7x plus 3 times x to the minus 2. Isn't that the same thing? Times x to the minus 2. Because dividing by x squared is the same as multiplying by x to the minus 2. This is how you sort of bring the denominator up using a negative exponent, turning it into multiplication. Why did I do that? The purpose is so that now I can distribute. But before I do that, can I just say I see a lot of bogus, a lot of people do this wrong. They say, don't write this down because I'm about to erase it, but they're like, I gotta move the x squared up, and they do it like this. I hope you agree with me. I'm here to tell you this right here is not equal to that. This is a whole bunch of stuff divided by x squared, and you're just like, oh, I don't like that divided. I'm going to make it subtracted. I hope you don't really believe that dividing is the same as subtracting. They are different operations, right? So when you're dividing by x squared, you can't just write that as instead I will subtract x squared. That's completely different, all right? The proper way to do this is like that. Dividing by x squared really is the same as multiplying by x to the minus 2. That's multiplying by the reciprocal, which is the same as dividing. All right, forget about that. Don't do that. What do? You do like I said, you multiply using a negative exponent. And now I'm going to do the same thing that we did in the previous example, which is I'm going to distribute and then do the integral. So distribute like this, right? Here, here, and here. What do we get? I'm still writing the integral sign here because I didn't do the antiderivative yet. I'm just simplifying. 5x squared times x to the minus 2. Again, you should be adding the exponents, and I get 5x to the 0. X to the 0 is 1, so that's just 5. And then minus 7x times x to the minus 2. You add the exponents, I get x to the minus 1. And then finally plus 3x to the minus 2. All right. Everybody good with that? I'm not done yet. I'm just simplifying. All right, the next step is when I actually do the antiderivative. So in the last step, I'm not going to write the integral sign anymore because this is the step in which I'm going to really do the antiderivative. What happens to 5? A constant by itself just becomes the same constant times x. So 5 becomes 5x minus 7. What do you do with x to the minus 1? This was the special rule, x to the minus 1 power, or if you see 1 over x, which is the same thing, this is natural log absolute value x. Plus 3, and then here we do not require a special rule. X to the minus 2 is just, you increase the power by 1, it becomes x to the minus 1, and you divide out by that same power. So it's like that. This is my answer. You know, you probably noticed this already. Sometimes there's opportunity to simplify after you do the integral, but I don't care about that. If your job is to do the integral, you should just do the integral. You don't have to simplify unless there's a good reason to, like I always say. All right. Any questions about that one?